Okay, so this video is looking at the quadratic nth term. So at first it might not seem any different to the linear nth terms that we were looking at earlier. But let's think about why it is different. So let me write this down. We've got 5, 11, 19 and 29. Okay, let's do exactly the same procedure as we did before. We find the differences. So what are my differences? The difference between 5 and 11 is 6. Okay, 11 and 19, that's 8. And 19 and 29 is 10. So can you see here that the difference between the linear equations is that the second line of equations here is different, okay? Whereas in the linear equations, these were exactly the same values. So what we need to do now is we actually need to make another line of equations. So I'm going to do this now for us. So we need to draw in another sort of bunting thing. And what's the difference between 6 and 8? That's 2. And the difference between 8 and 10 is 2. So now we've reached a point where the bottom numbers are the same, which is what we like. Okay, so into the nitty-gritty parts now. So there are some formulas that you're going to have to remember. These aren't too hard. Once you've used them many a times, they're like the back of your hand. So the first line of equations is A plus B plus C. The second line has the form 3A plus B. And the last line is 2A. Now you're probably wondering what this means, okay? But what this means is that we can use these formula to find out the value of A, B and C. And then we plug it into a formula at the end and we're done. So what we need to do is we need to work from the bottom to the top. So we're going to start with this 2A. And what we need to do is we need to set this equation equal to the first number on that line, which can you see is 2. So we're going to have 2A equals to 2. So hopefully you can see here that that means that A is equal to 1. Okay, the next step, we need to go onto the line above. So we're going to move on to this equation. So we have 3A plus B. And remember, we set it equal to the first number on that line, which is 6. So this time I have 3A plus B equals to 6. Well, A is equal to 1, which means that 3A is just going to be 3, plus B equals to 6. Which hopefully you can see means B is going to equal to 3. Okay, and the last thing that we need to do then is we need to consider this top line. So we have A plus B plus C, and hopefully you're screaming out to the computer that this has got to equal to the first number on that line, which is 5. So now we have A plus B plus C is equal to 5. We know what A is 1, B is 3, but we don't know what C is yet. Well, looking at this, 1 plus 3 is 4, so that means C has got to be 1. Okay, we're nearly done, I promise you. So the final thing that we need to do is we need to plug it into this equation. So the equation is an squared plus bn plus c. But we know what A is, we know what B is, and we know what C is. So A is 1, so I'm going to have 1n squared, which is the same as just n squared, plus 3n, plus C, which is just 1. So this is my formula for the quadratic nth term of this sequence. Okay, so if you didn't understand that, have a look at my other videos and see if you can get your head around it in them.